to solve rational equations by the cross multiplication method. Please remember that the cross multiplication method you only use when you have a proportion, when you have one ratio, one fraction on each side of the equal sign. So here's how the cross multiplication method works. We're going to multiply this way, and then we're going to multiply this way. Okay, so if you multiply 2x minus 3 times 3x, and then you set that equal to x parentheses x plus 11. I don't know why the screen is doing this. Anyway, so when we do here, I'm gonna distribute the right side since I already have the red color on. We have multiply x times x, and we have x squared. Multiply x times 11, and you get 11x. On the left side, we distribute this way, and you get a total of 6x squared minus 9x. Since this is a quadratic equation and we have variables on both sides, and we have it's a quadratic equation, so we have an x squared, we want to move everything to one side of the equal sign. So I'll go ahead and start by subtracting x squared from both sides and 11x from both sides. When we do that, we're going to get a total of 0 on the right side because they add up to 0. And on the left side, we get 5x squared minus 20x. The way to solve this kind of quadratic equation is by factoring the greatest common factor. On the left side, 5 divides both 5 and 20, and they both have at least an x in common. So we factor out the 5x and we get x minus 4. By the zero product property, if two numbers multiply to 0, that means either the first factor is equal to 0 or the second one is equal to 0. And solving for x here, we could see that 5 times 0 makes 0, and 4 minus 4 is 0. So here are the two solutions: x equals 0 or x equals 4. On the next example, I'm going to show you how to check these answers graphically on decimals on a graphing calculator. But for now, let's go ahead and multiply. Let's go ahead and multiply or solve equation or example 1b. If you multiply this way, you get 3, 2x plus 4. And if you multiply this way, you get x plus 2 times x minus 3. Again, since I already have the color on the right side, I'm going to go ahead and start distributing the right side. I have x squared minus 3x plus 2x minus 6. And on the left side, we're going to get 3 times 2 is 6x, and 3 times 4 is 12. Again, it's a quadratic equation, so we're going to have to move everything to one side. I'm going to start by simplifying the right side first, because we do have some common terms. Okay, and subtracting 12 from both sides to make one of the sides equal to 0, and subtracting 6x. We're going to end up with 0 on one side. We're going to have an x squared, negative 7x, and a negative 18. So this is a quadratic equation, a trinomial. The way we solve this equation is by factoring. So we can see here that x times x makes x squared, and the two numbers that multiply to 18 and add up to negative 7. Let's consider that positive 18 only. 2 times 9, 3 times 6, and I think that's about it. So out of these pairs of numbers, the ones that we could only combine to get a negative 7 would be 2 and 9. And obviously the 2 is positive and the 9 is negative. If you don't know how to figure those signs, just play around with them until you figure out what makes negative 7 when you combine them, when you add them. Okay, so at this point we use the zero product property. X plus 2 is equal to 0, or x minus 9 is equal to 0, meaning x could be negative 2 or x could be 9. One of the things that I didn't mention before was that sometimes we end up with extraneous solutions. I mean solutions that seem to be part of the answer set, but they are not. So for example, if you try to substitute negative 2 here on the original fraction, you're going to see that you're going to end up with division by 0. We're not allowed to divide by 0. So we say that this looks like a solution, but it's not a solution. We call these set of solutions extraneous. Oops. In this case, the only solution is x equals 9 because 9 does not give us a 0 denominator in the original problem. Now I want to do something. I'm going to check that last problem by graphing. You can always check your answers by graphing if you have a graphing calculator or access to internet, and go to Desmos. So I already have those two equations pre-typed here. So if I just click on it, it's going to show me the graph of the left side. And I'm going to say that I want to find out when that is equal to the graph of the right side, which in this case is blue. And please notice how these two graphs, the blue and the red one, the left and the right side of the equal sign that we had, only intersect at one point. You can zoom in or zoom out or change this until you figure out, but the only place where these two graphs intersect is when x equals 9. When x equals 9 is what the solution we found on the other problem. Remember that? X equals 9 is the only solution. Okay, so here's two examples on how to solve rational equations by cross multiplication. Please remember that you could always check your answers on Desmos or a graphing calculator. And don't forget to always check for extraneous solutions. What you have to do is substitute into the original equation. If you don't get division by 0, then most likely that is a good answer. All right, see you next time.